Good morning, good afternoon to everybody for joining. Thank you for taking time to join us today. We will kick off in just a minute or so. I appreciate you all logging in. We've got a packed agenda today, lots of great conversation, and really looking forward to hearing your feedback as well. So again, this is Gamil Gran here at Mayfeld. Really appreciate you taking time to spend with us this morning, this afternoon, depending on where you're at. And hope everybody's having a good spring. All right. All right, so it's top of the hour, and let me go ahead and just kick it off. Again, this is Gamil Gran here at Mayfeld. Really appreciate you all taking time to spend with us. Over the course of the last few months, for those of you who've been involved, we had a number of conversations about AI strategy, technology, roadmaps. We had a chance to talk to the Google team around the origins of AI, OpenAI team. We had some Harvard research work done. We got into some early use cases. And what we wanted to do today was really share a little bit more perspective, both from Mayfeld and how we're viewing the investment landscape from a market opportunity standpoint. So Vin Sharma will spend some time sharing that with us here, who is leading our partnership here at Mayfeld. And then we'll also have three different technology providers who are solving what we think are the first order blocking and tackling issues around data governance and trust and access to data in an effective way. And this tends to be the problems that we hear from CIOs broadly. So this is the agenda. And again, I say it's packed. So we're going to get through the content as efficiently as possible. But as always, love your questions. So please use the chat to suggest your questions. We're also going to do a quick poll through the middle of this as well to gather some feedback from you. So with that, let me turn it over to Naveen to sort of kick it off on our perspective.
Thank you, Gamil. Just seeing the counter go. So we crossed 100 participants. So really want to thank everyone. And I think it's going to keep increasing. So I'm managing partner at Mayfeld. I have like roughly 8 minutes to go. So for those of you who don't know us, we are an early stage venture capital firm, started in 1969, focused on having a team with an entrepreneurial DNA. In our history, we have raised 20 early stage venture funds, currently have 3 billion under management. In our history, we have invested in over 550 companies, of which we have been lucky to participate in 120 IPOs and 225 acquisitions. Next, Camille. Today, we have dry powder of approximately 1.2 billion to invest in early stage startups, and our AI Start Fund invests in companies at day zero, or what's called seed. 250 million. Mayfeld 17 is our early stage flagship product. Invests in like bigger seeds, what we call inception rounds. They could be watermelons, they can be mangoes and Series A's. And then Mayfeld Spring invests in early breakout companies post Series A and also at Series B. Next. Our thesis in AI is that AI plus humans is human squared. AI should really be used to elevate humans and not displace them. So humans, the first wave of AI technology was all about robotic automation of tasks. Now we had humans with assistants or co-pilots. In the future, we're going to have assistants with humans in the loop. And finally, as assistants become digital co-workers, humans get the chance to become superhumans. Next. So here is our perspective on the AI era. We are calling it cognition as a service. If everybody recalls, we had infrastructure as a service, which was focused on IT. The next level up was platform as a service, which was focused on developers. The next level up was software as a service, focused on line of business users. So in the cognition or the AI era, the first block, which is the IaaS, we are calling it the cognitive cloud infra. So this has all the all the infra software, but this is provided by the big clouds. Above that, you're going to have models, which could be multimodal. You need things like model trust, safety, evaluation, test. The next layer up is data. So you need data infrastructure, you need data operations, data security. The layer above is middleware and tooling for people to build apps, and also assistants leading to digital co-workers. We have 3 companies today which are going to talk about the models layer, the data layer, the middleware, and in the future, you'll be hearing more from us around intelligent apps and the whole future of agents, which is becoming assistants. And then eventually, the workforce is going to become hybrid, where humans will have cognitive workers or digital workers as their teammates. So if we go to the next slide, the count is up to 159. Let's see if we break 200. So this is what cognition as a service means to us. This is where machines or digital co-workers are going to work with humans, and humans get the chance to become superhumans. It starts with 5 A's. So it starts with automation of mundane tasks. The second thing where the market is focused today is acceleration of productivity. These two will lead to augmenting our capabilities with co-pilots. If we do those first 3 things, it's going to amplify our creativity, because we'll be able to do things which we haven't been able to do in the past. And finally, this whole thing will help us advance from humans to superhumans. And in a nutshell, that's what CAS, cognition as a service, is. And it has endless possibilities over the next decade, over the next 15 years, and over the next 20 years. Gamil, back to you.
Great. So I'd love to just get some feedback from folks. I'm going to launch a little poll here. This is a multiple choice poll, and Rehan, we have you teed up next. So I'm going to stop sharing and let you bring up your slides while we do the poll as well. And what I want to do is really have you think about how enthusiastic you are about AI. I know there's been a lot of conversation. Choose as many answers to this poll as you want. It's multiple choice, but you can have multiple yeses, if you will. I'm curious to see, are things different for folks and how you're pursuing things differently? And the poll, I think, can help provide some guidance to us on how you're thinking about the market. But thank you, Naveen, for your input here. Rehan, I'm going to turn slide control over to you. And as always, people keep chatting. Use the chat bar to suggest a question if you'd like. I'll bring you in and let you ask your question live, so that you can challenge us with some thoughtful insight, either from your perspective or a question you believe we all need to be considering, or just input in general to the conversation today. So with that, Rehan, I'll turn it to you.
First of all, thank you so much for hosting. I have roughly 10 minutes, Camille, right?
Yep.
So what we'll go over is that as organizations want to utilize their proprietary data with the LLMs to actually create all the value, the need of understanding of all the unstructured data and structured data, of course, goes even more higher. Now, while structured, I think, was being handled before in a certain way, now unstructured takes almost like a center stage on how do you actually deal with knowing what unstructured data is there and how are you going to bring into the generative AI pipelines. So to establish that, there's a whole construct that what if there was a knowledge graph around the data that you have across any of these different environments. And in that knowledge graph, it has a view of understanding of what files may be there, what kind of sensitive information may be on those files, what purpose they're sitting in organization, what type of files are there. And if you had the ability to, through one API, understand your entire data landscape from structured and unstructured side of things, and then be ready to utilize this proprietary data that you have as a value to be used with generative AI applications. This is really the construct of what we call as a data command center. Of course, we learned from many like yourself and maybe yourself, that is kind of need of the time to have a command center around the data. Now, in addition to knowing what data is there, if this knowledge graph would also have understanding of what's the applicable regulations and your enterprise data processes that are operating on top of it. If that was available, which is literally part of what we call as data command graph, then different kind of the control needs that you have, from security of data to general governance on unstructured and structured data and privacy of data, can all be done in as blades on top of this knowledge graph. I'm going to give you an example of how we're looking to have this be utilized for generative AI applications. So if you go to the world of generative AI, literally, this is the modern, the advanced kind of modern application is going to look like. You're going to take the data anywhere which is sitting in these systems, combined with the most appropriate large language models, SLMs, your custom models, to create all the innovations on top of it, whether you're creating agents and assistants and insights on top of it. So to do this, again, regardless of what data is, you have to marry it with the right models, which are available in any of the cloud environments. And the construct of one contextual knowledge graph actually provides the ability to pull the data from wherever it needs to be pulled through and bring it to the right pipelines kind of along the way. And I'll give an example of the typical pipelines that we are seeing, whether organizations are trying to build their own knowledge systems for applications where people can go ask the right questions in an easier way, or using these pipelines for tuning the existing language models, or of course, in some cases, also training their own custom SLMs or LLMs using this infrastructure, but it requires the data to be brought into the mix. Simply want to highlight that just like structured was used for BI and the whole ecosystem of capability was needed, we're seeing on a daily basis this need to understand unstructured data and catalog it, discover it, understand why is it in the organization, what's the purpose of it, and associated things that we have always been thinking about on unstructured or on the structured side, like quality of the data, like lineage of the data, like compliance on this data, access entitlement on the data. You can almost draw a parallel of that, of the entire stack that existed on structured to be on the unstructured side. And that's something that we are looking to provide along the way. Just for the brevity of time, I'll give you an example of a typical pipeline that typically needs to be built, and I'll show you maybe also an example of how it's built in a product also. This unstructured data, structured data, anywhere, people are trying to create prompts and agents and orchestrations on top of this data. But to do this, data has to be married to these models, which means the most appropriate data has to be selected, and it has to be ingested and extracted from different type of formats. You may have PDFs and audio files and video files. It has to be extracted properly. It has to be sanitized automatically. And of course, in this use case, you may have to convert into vectors. This is all can be controlled by having a knowledge graph around it, which can help with the selection of the right data, which doesn't violate your internal controls, or doesn't violate your entitlement issues, or doesn't violate your the governance that you actually want to put on these pipelines. And also, it can help with the understanding that what kind of sensitive information needs to be taken out and detected, as well as redacted or sanitized or anonymized along the way. And if you can combine with the most appropriate embedding models to convert into vectors and provide this to the retrieval engines in a way that can be, retrieval engines can talk to your data in a vectorized form in a safe manner. To do that, of course, you need some kind of a guardrails around it to make sure that there's no model poisoning and data poisoning kind of going on. And of course, the retrieval engines are guarded by certain rules so that your data is not carte blanche being used by these models along the way. And then when this interaction of the prompts that coming into your retrieval engines, those prompts need to be inspected because they could be malicious, could be mistakes, could be insider issues on those prompts or deliberate attacks going on. And the responses that are given out by the retrieval engines to make sure that also they don't have any exfiltration going on, or they don't actually have mistakes going along the way. This is simply an example.
Sorry, Rehan, we've got a couple of questions for you that I'd love to have you perhaps answer. First one was typed in by Larry Fitzpatrick, and Larry, I've turned your mic on, so maybe you want to ask your question, but really having to do with this concept of a command center and why it's uniquely needed today. And Larry, go ahead and maybe answer or offer more to your question there.
Sure. Yeah. I mean, the idea of having a centralized mechanism for understanding what data we have, making it simple to use it and reuse it has been a bit of a holy grail in information space for, going on 75 years. And we've never ever been able to achieve it because classifications generally break down the larger they get. But we've been able to get by, right, by doing just enough to make data accessible when and where it needs to be accessible, protect privacy, and so forth. So what's unique about this moment in time when a all-knowing, all-seeing data command center needs to be in existence and can come into existence that's different than before?
Larry, it's a fantastic question. I think a couple of things are coming together. One is the need itself, that people want to utilize this data unstructured in a very different way in LLM. So need is definitely a rise. So you can say the same thing about structured data before, but now understanding of the language that the LLMs bring, you can classify in a much more high efficacy way this information. But again, you still need to actually have the metadata that needs to be available. So the construct of this, what I call a knowledge graph here, can allow the ability to literally have one place where across all clouds, across all SaaS, what object storage may be there, what streaming services may be there. And when knowledge graph, you literally actually have understanding of any of the file level to say, if this is my audio file, tell me like where it's sitting, who has entitlement to it, what's inside that file. That's the level of knowledge graph you're able to build now with the use of the generative AI itself. So generative AI is helping to actually do the part which is very difficult. The knowledge graph constructs can actually bring all of these things together where you can literally ask questions from these systems across any of the entities. And the utilization of the unstructured data also drives the need of it in a very different. And regulations like now you have EOI Act, you have NIST, you have all new regulations actually popping across, which frankly is the opportunity to actually think of this as the need of a data command center. And I fully align with you that even when you have a data command center, you still may want to do selectively, that you may not want to say, just do it all. You may say, look, these are my most important repositories. And I want to actually address them first, and then address the others, along the way.
So is this essentially a facilitator for a better enterprise search? Essentially.
Actually, so enterprise search will be primarily tied to just any questions that you ask for the content itself, right?
Yeah.
Whereas in a command center, what you want to do is to have all the metadata associated with it and have the ability to build these generative AI pipelines where you can literally pick the data where you want to pick from. You want to sanitize it. What you want to do is to then marry it with the most appropriate LLM models kind of along the way. And then, of course, use the place where you can essentially, keep it safe, which means if you want to have all kinds of, safety guardrails as part of these pipelines, they're actually safe kind of along the way. The point really is being that the need of the use of your proprietary data is now a very, very different and opportunity for upskill is there, but it's not enterprise search itself, because you need the associated metadata and the lineage information to also be available. Like which files are getting used in pipelines, you would just want to know this file came from which system, which user's entitlement to it, which location it came from, and what is my control constructs which are needed. So before I put this in the pipe, or if the file is already in the pipe, I want to know that who can actually touch this file or the embeddings that are created from this file. So this whole construct is kind of evolving very, very fast with the possibility of this generative AI.
It's a question here about synthetic data from Maximilian, and Maximilian, I'm going to answer ask your question as well. And you're getting a lot of good questions here, Rehan, so I'm trying to pop through them here. So take a look, and maybe we can answer more of them here as we go through.
Yeah, definitely.
Yeah, so I think...
Go ahead.
Sorry, I also understand there's quite a few questions and you want to kind of go deep through the rest of the presentation, but I'm just curious. So my name is Maximilian Stein. I work deep in the AI space, and a big trend I've been seeing a lot is kind of the use of synthetic data, whether that be training new models, whether it be small language models, and also on the aspect of just privacy itself. So I'm just kind of curious of your perspective around this, and then also just overall of like leveraging these AI use cases and scenarios, especially in the enterprise space. A lot of data is very confidential with a lot of regulation, and it's hard to get access or use that data. So I'm just curious to areas of kind of like navigating that and where and what to use properly.
Yeah, I think so. Synthetic data unquestionably is for structured data, as part of a pipeline, if you can pick up on, instead of the original data, if you can pick up on the a synthetic version of the data, particularly in the structure side of things, mathematically you can remove the unique tie back to the individuals, is useful. But it's not useful in many other situations where you still need to clean the data. Let's say if it's your audio file, and in that audio file you want to know that certain things, you want to actually figure it out, that let's say in this example, this audio file actually have very specific information of sensitive information at a very specific point in time, and you want to take it out. You may need to apply different techniques to actually remove and redact this information. So it's a very important part of your toolkit, but it's applicable in certain situations. And particularly in the generative AI pipelines, when you're picking data from the structured side, you can apply as part of the pipe itself. But it's one of the aspects in the toolkit itself that you'll be needing.
So Anju from Kroll was asking about guardrails as part of the implementation. Anju, I've turned your mic on as well. We might not get to all the questions, so Rehan, maybe after you're done presenting here in a couple minutes, you can maybe answer some of the questions via text as well, or in the chat bar.
Yeah, hi Rehan. First of all, great concept. I'm loving this. I just came back from the Databricks CIO forum, and this is like just additional awesome stuff. I want to understand how you are keeping your AI models secure, and if it's not a secret sauce, what guardrails are you putting around it?
Yeah, no, I think this is a fantastic question. Thank you for asking that question. So in the AI construct, these are 5 things you can see my slide, right? And I'll show you the firewall construct also. These are the 5 things you have to discover the AI models in an organization, because there's a groundswell going on. So shadow AI is a real thing, right? The risk rating, a lot of work going on, how you attach, and I'll show you that these are as a step 2. Once you actually have this, you need to know the ratings of the models. So in terms of guardrails, what data is going into these models for tuning, training, embeddings, vector creation, has to be monitored. You have to have a graph view of it to say, this is my data going into these models, and this is my graph view. And ability to insert the masking sanitization on it to make sure that data that you do not want to go into the vectors or trainings, it does not go. Then on the prompt side, what you want to do is to make sure that the inbound prompts that are coming in, they're inspected and blocked from any prompt injection attacks kind of things. And the answers that are being given, they're also inspected using a firewall, LLM firewall. And then compliance is a huge driver. EU Act just got passed. NIST ARMF is already in place. And there are at least 15 other AI regulations. So this literally what we call is a 5-step approach. Discover the models, assess the risk, bless some and block some models that you never allow in your environment, map the flow in a graph form. that this is my model, this is my data, this is what's going, have a view available always as a lineage view, and then ability to control. Insert the controls, both the inbound of the data and the outbound of the data, and have the control compliance be there. So literally, this is, and I'd love to actually go in a lot more detail of it on each topic, how this can be done using either inline inspection and sanitization, and then LLM firewalls, which have policies defined for you to understand if this is a jailbreak instruction or offensive content or exfiltration of content is going on. This is an out-of-box policy that you would need, which can understand natural language construct, not a typical firewall of IP addresses and URLs, but a natural language that can understand and stop things from happening. But it's not just the firewall itself, as I explained, across the entire your journey of knowing the models to here is the whole program that needs to be actually put in place for security of AI.
Rehan, this is excellent content, and of course you're getting all sorts of questions. If you could stop sharing, I'll let Ram come up now. And Rehan, if you wouldn't mind staying on and answering perhaps some of the questions that have been texted here. And just for everyone who's attending, thank you again for being here. We are capturing all the content. We're capturing the recording of today's call. We'll share all of this content and connections. For instance, if you want to reach out to Rehan, et cetera, we'll make sure all of the follow-up materials are all available to you and your teams as well. So with that, let me bring up the Semaphore team, both Rob Bearden, CEO and founder, Ram Venkatesh, CTO and co-founder, are both here today. They're going to share a little bit of their vision with regard to Semaphore, where they're at as a company, but amazing founding team here who were previously founders of Hortonworks and then Cloudera, very successful open source enterprise operational chops in the big data world. So Ram and Rob, welcome.
Yeah, great. Thank you. Ram and I are going to tag team this. Let me start very quickly with saying thank you to Mayfeld for letting us be part of this today, and the applicant and all the participants that are here today, and your time and listening and hearing about what we're doing and giving us feedback. To kick it off, the Semaphore mission is about really how we enable the enterprise to be able to build, deploy, and manage intelligent AI agents. And we're going to be the execution application that's based on the cognitive architecture and plumbing that we provide and enable. And we all think about this, I think over the last 12 to 18 months, I don't think any of us would be here today if we didn't believe that generative AI and LLMs are probably one of the most important enabling, I think is the operative word here, enterprise technology in the last generation. But I think what we have to realize is that it is enabling technology, and that if we look forward, every company is going to need an intelligent agent to be able to capture this enabling technology and apply it in the enterprise in which it creates and captures value, and can be done with all the enterprise capabilities that are required for managing and accessing data in and out of the models, and to be able to leverage the data through the generative AI structures. And that's really what we're focused on our intelligent agents, because we believe that our intelligent agents are going to be how the enterprise is going to interact with their customers, their supply chain, their employees, and really even their products on a go-forward basis. And so what we're really focused on is how our intelligent agents deliver significant outcomes and enable high ROI use cases to function at scale very quickly. And so when you unpack at a macro what our intelligent agents are, the key aspects of them, it's very nuanced on its understanding of how a user's natural language queries are executed. And unlike the large language models or the RAG applications, we don't just respond to the prompts, but we actually provide the reasoning about and with full context of all the user's needs. And we anticipate what those needs are, and we determine the sequence of the actions that we want to execute. But we're informed by very short-term working memory, but also with a longer-term repository of knowledge that comes from a run book that we provide and a gallery of use cases that really reflect what the human cognitive processes are. And yet at the same time, our agents in our cognitive infrastructure give the ability to leverage the external tools and APIs that are really required to take these actions across both digital and physical environments and leverage both structured and unstructured data. And we'll unpack what that does. But the end result of this is that we're going to have massive value creation for the automations and use cases that we want to give the enterprise the ability to enable, and some of which we're going to make exponentially more efficient. Others are just new use cases that haven't been enabled yet, don't exist now. And so when we think about where the technology stack is, where we are in this journey, and we think about what the benefit for the enterprise is to engage now on building, deploying, and running and enabling these intelligent agents, it really comes down to achieving competitive advantage. And to get that competitive advantage, it's all about driving the velocity, capturing value, but doing it with a platform and architecture that's bringing flexibility to capture as the new capabilities and technologies emerge, the language models advance, that we can capture those in a very, very efficient way and leverage that very efficiently. And this nimbleness needs to happen, though, with a lot of accuracy, precision, and predictability, because you expect the best-in-class outcomes as you engage these agents, and that's what we're bringing forward. And so when we want to take you through how we do this, but this is something that you need to think about in a crawl, walk, run motion. And in order to get truly the reliable, predictable outcomes, you got to start small, get your first success under your belt, and then every 9 to 120 days, reiterate around how you do that. And building a center of excellence around how you operationalize this muscle, and how you create and measure the value capture and creation. So we're going to talk a little bit about that when we wrap up. So Ron, why don't you take them through a little bit more, double click into what our approach to this is from a platform standpoint.
Happy to, Rob. Hi, everybody. So I think as Rob was saying, right, we believe that this is transformative technology, but let's get really specific. So here's what an example use case could look like when you would apply generative AI in this fashion. So I picked a use case from one of our customers. They are a global electrical equipment manufacturer. They serve customers in probably 85, 90 countries. They have a small team inside their company that's cross-functional, and it just performs a very interesting function. So what they do is they have people who are monitoring a set of government websites as the export controls and the rules change around sanctions list, for example. And whenever they see that there is a new update from the website, they download the PDF. This PDF is analyzed by folks in the legal department. They come up with, okay, here are the deltas to the government policy. Here are the new agencies and individuals who have been placed on the list, for example. Then they have to turn around and see if that actually impacts their business. So to do this, they're going to go do some lookups in their backend systems to understand, is this a customer of ours? What kind of financial relationship do we have with them? And once they understand that, then somebody, again, a combination of account management, sales ops, and legal has to come up with a legal policy statement. Sometimes these could have ramifications like, if it's a large customer, for example, who was associated with Russia last year, there is going to be a material change in revenue from that customer. So all the way through to the CFO's office, there is impact that somebody has to put together and have them review. So these policy documents have very, very structured requirements to them. There's a template they have to follow. There's a review process they have to go through. And at the end of all that, it's actually published internally. So this entire workflow is something that could take a couple of weeks, 4 to 5 people. It's very, very material and consequential for the business, because if they get this wrong, not only do they have sort of top line impact, but they also have legal and compliance impact that they could be exposed to. And then they get to do this all over again, because the next update is going to show up every 3 weeks. This is an example of a workflow that humans are really good at. But if you take this workflow and you deconstruct it, you can see that this involves having access to unstructured data that's typically behind a paywall of some kind, being able to summarize and analyze that according to a narrow set of guardrails established for actually performing this process. Then there's queries that you have to make to backend systems that are very, very structured themselves. But the answers coming back from them, again, have to be used to create some unstructured content that has to go through a document processing workflow, and then you get an output from it. Typically, the day in life for somebody like who's doing this, part of this workflow or this process looks like that person in that swivel chair. They have a couple systems that they are looking at to assemble the data. They have a couple downstream systems that they're taking action in. And the promise of agents is to convert workflows like these to conversations like that one that I have listed above. So we understand that this is a very wide space. There's lots of applicability to a framework or a system or this way of thinking. So we listed some of the key elements that we have found very valuable as you're thinking about use cases. The first one is that many of these job functions, be it in compliance, be it in HR ops, be it in sales ops, be it in collectibles and receivables, all of these are very structured jobs. So there's a very well-known agent persona that you should be able to describe to this. There's a well-known set of standard operating procedures. These could be manuals, handbooks, training material, videos. In some cases, also, there's an exam that somebody has to take to demonstrate competency in that particular function. All of these are really good materials for us to train on as we establish the standard operating run books that Rob mentioned for the agent. And typically, when there's something to be done, there's a well-specified intent. There's a well-specified outcome that tells you whether the thing that you wanted to do actually happened or not, right? We think that these are very amenable then to auditability. You can say that this is how completion happened. This is what each of the steps of that process actually did. Here are all the calls that were made to the external systems. Here are the prompts fed into the LLMs. Here are the decisions that the LLM recommended. Here are the actions that we actually took in the backend systems. All of that, there's a complete history and an audit trail that's very, very relevant and important for a task like this. The other piece is for workflows like these, we believe that enterprise context is a really important part of this, which is why a lot of things that Rehan was describing in the talk prior, they are lifeblood to make scenarios like this work, right? To be able to access your enterprise context in a meaningful way, whether it's structured, whether it's unstructured. The humans are not thinking today about the data model. They are thinking about the question that they need answered. And that is what you need to facilitate. And the last bit, the opportunity we saw was that it's not just about giving the human an insight that then they have to go act upon. With the agents, we are now at a place where you can take consequential actions with very well-specified controls on what actions are allowed and what are not, and which ones require humans in the loop. And there's an entire new way to think about how the human works with the assistant to get their job done. But the key is that actions are also a part of this. It's about being able to go from a bunch of context, apply a set of procedures to evaluate what needs to happen, but then being able to take those actions in these downstream systems, in these external systems, publish updates so that other systems and people and other agents can actually consume. That is how we see this. These are the elements of a good use case. It brings all of these kinds of attributes together, and that hopefully gives you a sense of how you can go about thinking about what areas are amenable to this kind of cognitive or intelligent automation.
Hey, Ram, there's a question here from Larry
Yes.
Fitzpatrick, and you maybe touched on this a little bit, but he's asking, this is always the impact issue that businesses have to operationalize as they make a technology decision. And so what kind of metrics will you capture in the workflow itself? And maybe, Larry, you want to add some color to that.
Sure. Yeah. I mean, Ram, these are great examples of the kinds of manpower-driven intellectual toil that happens in lots of organizations that I think could be really enhanced by this. But curious if you have any real-world example of the kinds of impact metrics you're seeing, whether that be, efficiency, latency, consistency, quality, or something else. How are you measuring that, and what are you seeing in real world?
Let me
That's
take
it.
the first side of
Yeah,
that. And then
go
Ron
ahead,
can take
Rob. Yeah,
I'll take the business
absolutely.
workflow side, then Ron can take more of the technical proficiency side. So when we think about this and how we get started, we think about this and we're partnering with our customers in defining high ROI use cases that we can execute quickly and efficiently. And so we think about an example of that would be, instead of looking at really point-to-point automations for invoice processing, payment processing, things like that, where current automation as is either an ERP or RPA would enable hundreds or maybe even minimal thousands of automations to happen in terms of volumes of processing. We think about this in terms of how we can, instead of automating point-to-point payment processes, how do we enable an end-to-end order-to-cash cycle where we have many intelligent agents that are executing multi-thousands, if not tens of thousands of invoicing, payment processing, HR engagement workflows at multi-thousands, tens of thousands of scales from an end-to-end best-in-class process outcome. And those are is sort of the standard that we think about intelligent agents having the ability to deliver on. And our engagement model currently right now is giving you a run book, if you will, or think of it as a gallery where these templates are available that you can either leverage and add to, or you bring your own operating platform that either you're in compliance with your regulators, or it's your best practice standard operating procedure for an existing end-to-end process. We manage that through our run book with all the security, governance, and lineage standards around that, and the ability then to not only execute those automations, but with the AI intelligence to remediate the changes in automation as conditions and events change or evolve or emerge, so that we get from hundreds or low thousands to multi-thousands, tens of thousands. And we help you define what those ROI efficiencies are and what the value capture should be. We think about it in monthly and quarterly terms versus annual.
Hey, Ram, I wonder if you could take a look at Teja's question as well. We're going to run out of time. So one last question, maybe, Teja, I turned you on here. Please, I love your question. I also love your AI image. That's very cool.
Yeah, no, thank you. I think this is super fascinating for me, and I'm mostly thinking about how this is evolving, right? In the sense that you have all of these steps here, and from an interoperability standpoint, it almost sounds like we're getting to a stage where agents are talking to agents or systems are talking to systems. And I'm very curious how if you foresee this being a closed loop, hey, we express intents our own way, or we express the logic our own way, versus some sort of standardization on how it is actually expressed. Like this, just like we have programming languages to express logic.
Correct.
Do you foresee any sort of standardization there?
Yeah, I was going to say there goes the hour, because you have like 3 really good points that you make. I think I'm just going to probably add a little bit of clarity to a couple of those. Really, I think it's really good perspective for us to think about these. Is we view these agents as fundamentally all parts of our cognitive architecture are natural language based, because we believe that that's the best way to interact with agents. That's also exactly the way we interact with humans today. So if you think of how our users interact with our agents or assistants, it's through the messaging paradigm, through tasks like an inbox, through chat, through Slack and Teams, and through custom APIs. So this naturally leads to composability. So we believe this is the sort of rational way to multi-agent, where every agent has a purpose. And so to your point, how does this natural language give you the flexibility of interop while also giving you the precision of knowing that you're talking to the right domain agent? Like, for example, you don't want to ask a physics question to a travel agent, right? So we believe that, there's like the next level of sort of higher level semantic schemas that will come into play here, where Rob's Rob was talking about the galleries of agents and these templates, right? These are all ways for us to start to publish metadata that help us identify the agents that are appropriate for interaction. But we do believe that multi-agent is a composability problem, not like a turn of the crank where you got to do something very different.
Hey, Ram, I wonder if you could take a look at
Yeah.
Lindsay's questions, Matt's, Scott's, Anju's as well. If you could also bring down your slides, I'd like to bring up Vin now from Jill. Please keep the questions coming. I really appreciate the great dialogue here. Some people have asked if we're going to share content. We will share the slides from each of the presentations. We're recording the call. But Vin, let me bring you up. You've got a company called Vijil. You've got an amazing background having run a lot of risk issues for the SageMaker team at AWS before getting funded here at Mayfield. Why don't you introduce Vijil and the problem statement?
Thanks, Gamil. It's really good to be here. It's also great to actually follow Rob and Ram, because a long, long time ago, as part of the Intel big data team that partnered with, invested in Cloudera, I still wear the t-shirt that says, "Data is the new bacon, never gets old." The t-shirt's in pretty good shape too. So it's great to follow their topic. And it's also specifically valuable to kind of have that context of agents, and particularly multi-agent solutions, because that's kind of what consumed my interest quite some time ago when I was starting to build a private cloud data center infrastructure for BMW's autonomous driving program. And that led to the notion of agents that could be deployed not only in the cloud, but on devices at the edge. And one of the motivations for joining AWS to build the SageMaker deep learning platform there for 5 years. And it was in the course of, seeing enterprises kind of pause between the potential of new technologies, particularly open source technologies like foundation models today, and their deployment in production at scale, particularly on systems that were out in the real world. That was the motivating factor for Vijil. It's a company that we think should help enterprises, agent developers, specifically folks like Semaphore and their customers who are building and deploying agents, to infuse trust and safety into the agents as they're being developed, rather than as an afterthought. And if you kind of see this play out in the long run, we do expect a world in which there are many different types of agents. There's certainly going to be agents that are personalized to individuals, and also agents that are customized for organizations. And most certainly they will be interacting with each other, but there's very likely to be many intermediate agents that sit in the public sphere, some of which are actually quite well behaved and normal, but there may be others that are antagonistic, hostile, and so we cannot assume that the world in which the agents interact with each other is going to be a benign and friendly world. There will most certainly be bad actors who build bots that are designed to be harmful to other agents and to other users. And so that's part of how we see this world. But even as we look at today, before we get to that end state, even as we see developers today building LLMs and then customizing them and deploying them inside applications, whether they be RAG or agents, we see a variety of risks that have to be addressed specifically at the model level. So I think in large part, one of the reasons why I have a particular take on this is that we see models as the first-class citizens, and we certainly take advantage of the data protection mechanisms that Rehan at Security is building, so we would build on top of that. But even if you focus specifically on the model, there are a ton of risks specifically along the lines of attacks upon the model. And once the model is compromised, if it can actually then harm other users that are innocent bystanders, if you will. So these are the types of issues that we're focused on. And if you look at the history and the literature on the subject, there's a ton of work on many potential ways of attacking systems, ML models, and the data that drives them. And now that's true for agents as well, as you start to build in capabilities, agency into the systems. And we've looked at the full taxonomy of attacks and possible ways in which these models can be compromised. But ultimately, and this is sort of a tongue-in-cheek representation of how you should see it, we see today's approaches, the state of the art for LLM security and safety, to be kind of focused on this inbound vector of prompts and prompt injections and potentially blocking them and filtering them through LLM firewall or guardrails that prevent harmful outputs from going back out to the end user. Perhaps some amount of alignment based on reinforcement learning with human feedback that puts a friendly face in front of this this kind of fast LLM behemoth. But under the hood is this monstrous entity that has been trained with all of the internet's, for better and for worse, garbage and benefits to produce whatever it is that it produces. And it doesn't seem to be an area where we see as much attention being paid fundamentally to the nature of the model itself. And that's why we think that the way to approach this should be sort of two-pronged. There's certainly the approach of finding vulnerabilities to attack in the models and detecting propensities for harm and being able to do that through some kind of an evaluation or scanning mechanism. But there's also, coupled to that, this idea of a blue team that kind of matches up with the red team. And the blue team and the red team work together to find and fix vulnerabilities and these propensities on a continuous basis, adapting as those attacks adapt and change, and to do this fast enough to where it doesn't block the model developers and the agent developers from deploying them into production. So the way we built processes like this into the AWS AI organization, where I led the deep learning team, was to really bake in, sort of do the classic shift left of security into the development process for AI ML development. And you've seen trends or movements like ML SecOps reflect that position. But in some ways, I think even with ML SecOps, it feels like the point of insertion is reflected in the name. The security should go even further left into the design, to the development of the model itself. And so we see this coupling of the red team and the blue team as something that you bake into the agent and the model development process. And so what we started out with was just this fundamental idea that you can't improve what you cannot measure. So you have to first measure trustworthiness. And today, trustworthiness is barely well-defined, leave alone measurable, and has metrics for it. So we started out building those metrics, putting together an evaluation framework that lets you measure the trustworthiness of a agent or a RAG application or the model specifically inside it, and to test this at scale, to do it really, really fast so it doesn't interrupt your development workflow. And then once you do that, to build essentially what looks like a holistic envelope, a dome, if you will, that protects the model and the agent holistically from both inbound and outbound issues. And so just to give you a quick example of how we've manifest this analysis and this evaluation, we generate a trust report and a trust score, sort of like the credit score that you might associate with an individual, but you can associate then a trust score with an agent or an LLM. It has 8 dimensions today. We couple this to the performance, so some notion of competence that we can also test, because ultimately these are trade-offs that we see developers making. If you improve the robustness, for example, it's possible that when you train the model with out-of-distribution example or so synthetic data, while the robustness of the model improves, its accuracy under certain conditions may reduce. And so you have to make trade-offs across these 8 dimensions and other things related to the competency of your model. So with that, I'm just going to pause here, turn it back.
A couple of questions for you here, Vin. Sure. So one from Anju: is the scoring dependent upon the use case itself? And I know, Anju, maybe you want to ask your question more specifically, and Stuart as well, asking for a vision of where will we be maybe a year from now.
Yeah, I can talk a little bit about my question, because we are benchmarking and we are doing some of this trust score work, but we have a couple use cases in production. And the question that I always have is, do I need to do the trust score for each use case independently? or I just do one and be done with?
I don't think that there's ever going to be a situation where you're done with the evaluation. But that said, I do think that the evaluations can be extended and customized, and I think they are business case or use case specific. Although there are some common patterns across model architectures, model types, and so we do think that it's not an either or, it's both. You start with a base set of capabilities, prompts that we, in our case, the way maybe I'll go to a particular illustration of this really quickly. Where we're starting with, for example, is a set of common goals that we think are, that every attacker, in some sense, would try to disrupt the operation of an agent or a model. And if you imagine there's, like we've so far identified 100 such goals, these are fairly use case agnostic. We should be testing for these types of potential attacks from any source under any condition. But for the specific use case that you're looking at, perhaps it's a bank chatbot. The bank chatbot, in this case, that's representing a customer service agent, has access to a backend database, maybe is not today enabled to write to the database, but certainly can read from a database. If that were the case, then you want to make sure that it represents the organization's policies and standards for customer interaction, that it has obviously no toxicity in the way that it interacts with your customers, that it protects the organization's brand identity, that it's not recommending other brands for simple questions, and it does not disclose personally identifiable information, right? So there's a bunch of things that are unique to what a bank chatbot does. That would mean that the evaluation of the bank chatbot is highly customized. But at the same time, as an agent, as an LLM model, I think it's vulnerable to a number of different attacks, and you would do a broad range evaluation for that purpose.
So Lawrence is asking a question about how you weigh the various elements in the model, and what's the math behind that, and how is that controlled? And Lawrence, maybe you want to ask your question as well.
Yeah, I'll add to that. And first, shout out to the Georgia leadership here with Rob for support at UGA and Vin from Georgia Tech. So go Tech, go Dogs. Hey, Georgia in the Valley, that's a good thing. So yeah, and I just think the 8 elements, I think that's pretty keen that y'all picked up on that. I'd like some insights on that. And I assume as you progress your business and you get into really large enterprises, you'd have an entire policy-driven governance model around it so that you would allow the admins to be able to skew toward one of the 8 elements more than other from a weighting standpoint. Is that the direction you're going?
That is exactly right. We already do this today. We have a weighted mean. So right now the weights, as we ship out of the factory, if you will, the evaluation framework is equal weight to each of these sectors. But absolutely, it is, as I was saying with the bank chatbot example, we expect our customers to adapt and modify for their use case.
That's pretty cool.
So CodeGen Copilot, for example, less concerns around toxicity, much more about package hallucinations, making up names of GitHub packages that somebody could then intercept and create and have, backdoors and Trojans inserted into, right? So those are issues that we anticipate.
So Vin, another question here from Matt. And how do you establish, and Matt, I've turned your mic on. So maybe you could just ask your question directly, and then Stuart, we'll close with you because yours is a forward-looking view. And then I did put up the polling answers, and I'll share all this content as well, but we're down to the last 2 minutes and I want to overstep my time with you. So thank you all. But Matt, you want to ask your question?
Yeah, thanks for this great, session. The question is simple, one of the challenges is how do you establish trust in a trust score, right? Why you, and in sources of basically explainability for the model, just like you have it.
Of course, yes. The report itself and the measures that we use, as well as the individual prompts that produce the particular responses and the evaluations, are publicly available to our customers. So we're transparent in the evaluation process. That is not where we're really, withholding IP, if you will. Really, the core of where we see Vijil evolving is in building those blue team capabilities that fix those issues, which we think are a much harder problem. almost every paper on adversarial machine learning today is about finding the upper bound of attack vectors that you can attack a model with, less so about building systems that can defend the model in depth or build defense in depth mechanisms more specifically. So that's where we're focusing on. We're happy to share the specifics of how the model is evaluated and adapt it as we go along.
Stuart, do you want to ask your question? And Rob, Bram, or Vin, maybe chime in on your vision of where we are a year from now in the remaining seconds we've got left. Here.
Yes, thank you, Gamil, for an outstanding session. Everybody has really educated us all super well. I feel like I've been in a PhD qual session right now. My thoughts are there's so many dynamic things going on. Where do you think we'll be a year from now?
I think my perspective is we'll have learned a whole lot in this year, even of how to build systems that use all these technologies. The pace of innovation here, I only see that increasing, not decreasing, which is why we believe open, interoperable, innovative ways to think about these problems are better than if anybody told you they haven't figured it out, I would be very worried for them.
Yeah, the thing that accelerates this is getting more and more content into the run books to get more leverage over the end-to-end process use cases that can allow us to go faster and further, if you will, with more velocity of use cases. That's number one. Number two, the ability to manage hundreds and thousands of agents in real time as they're executing these efficient automations is going to only become more reliant and sophisticated, and we'll be able to go from managing hundreds and thousands to thousands and tens of thousands of these and our ability to build them and deploy them, leveraging those models that I was talking about that come from the run books that get built over time, become more and more leverageable. So it just becomes a concentric flywheel that builds with velocity over time as we build each and every one.
Awesome. I would add to that with kind of the insight from the self-driving car and autonomous systems history that the L1 to L5, or the 6 layers of autonomy or levels of autonomy, is a useful taxonomy of how agents will evolve in other contexts and domains as well. And I'd suggest that we're kind of still scratching the L2, L3 layer or levels today. And it's not linear. There's a ton of work to go from L3 to L4. And that's going to keep iterating and evolving. And the agents will support each other as we do that. So I'm really excited about just next year making incremental progress on that scale of autonomy and collaboration.
Great. Well, thank you. I've overset my time by a couple minutes, and I really love to stay within the hour. So really appreciate everybody for spending time with us today. As I mentioned, we'll be sharing the content with everybody. We did record the call, so if you want to re-listen to the content as well, we'll have that for you. We'll also have contact information for anybody who wants to connect with any of the speakers today, and keep your questions coming. We're always eager to help support early adoption of new technologies. And of course, always thrilled to have you part of the Mayfeld CXO network. So thank you all. Have a good rest of your day, and we'll see you soon.
Thank you all.